Okay, so the last section of Chapter 7 that we do is 7.3, Applications of Linear Programming. So our goal is to turn word problems into those equations, or the types of equations we did in the last section. So your goal is to write all constraint and objective functions, graph the constraints to find your feasible region, get the corners, plug them in, and see which one produces the most desirable result. So as an example, Mr. Lee has nothing better to do, so he tutors math in his free time. It takes him 2 hours to tutor a student in college algebra, and he makes $75. It takes 3 hours to tutor a student at trig, and he makes $105. Mr. Lee already has 1 college algebra student and 2 trig students scheduled, but wants to maximize his profits in the 24 hours of free time that he has on the weekend. What breakdown of tutoring should he pursue? So we'll let college algebra be x and trig be y. So what do we already know? He already has 1 college algebra and 2 trig students. So we know that x has to be greater than or equal to 1. Y has to be greater than or equal to 2, because I already have those 2 kids scheduled. So let's talk about money and his hours. So the total number of students he can schedule in 24 hours is 1 college algebra student is $2. 1 trig student, or 2 hours, 1 trig student is 3 hours. So that means 2x plus 3y has got to be less than or equal to the 24 hours of free time that I have. Okay, and lastly, we want to maximize money. So we know that make $75 per x and $105 per y. So this should be my objective function to make the most money. But otherwise, I think these are our 3 constraints. So let's look at what this graph looks like. X is greater than or equal to 1. Let's go find where x is 1. Just this vertical line. We need y to be greater than or equal to 2. And then the last equation is the 2x plus 3y is less than or equal to 24. So 3y is less than or equal to negative 2x plus 24. Y is less than or equal to negative 2/3 x plus 8. So it looks like from a graph, we start at 8 and we go down 2 over 3. Down 2 over 3, down 2 over 3. And this is a less than equation, so this is our feasible region. So what are my vertices here? I've got 1, 2. Down here, I've got, it looks like 9, 2. And I've got, okay, so if we're talking about the top corner here, it doesn't go across at an even number, it looks like. It looks like it's gonna cross at 1 and then 7 1/3. Now I can't obviously schedule 7 1/3 trig students, but let's see what it looks like if we could schedule 7 1/3 trig students. Not realistic, but possible. So z at 1, 2, z equals 75 times 1 plus 105 times 2. That's 75 plus 210, which is 285. At 9, 2, z equals 75 times 9 plus 105 times 2. 9 times 75 is 675. 675 plus 210 is 885. It's a lot of money. then 1, 7 1/3. So technically z equals 75 times 1 plus 105 times 7 1/3. Okay, so 105 times 7 is 735, plus another third of 105 is 35, so that's 770. 770 plus 75 is 845. Okay, so if I want to maximize my money, maximize my profit of $885, if I tutor 9 college algebra students and 2 trig students. So that's the idea behind the word problems. You convert somewhat realistic scenarios into equations and go from there. We'll do 2 more. It may take 2 videos, but we'll continue in this video to the next problem, to a more reasonable situation that might be encountered. Okay, so earthquake victims need medical supplies. Okay, reasonable. Each medical kit measures 1 cubic foot and weighs 10 pounds. Each container of water measures 1 cubic foot and weighs 20 pounds. Each medical kit helps 6 people, and each water container aids 10 people. A plane can only carry 6,000 cubic feet worth of items and 80,000 pounds. Find the number of each item to be put on the plane in order to maximize the number of people helped. So what do we know? We'll let the medical kit be X. We'll let the container of water be Y. We know that the number of people we help, what we're trying to maximize, is 6 times the number of medical kits plus 10 times the number of thing of water. So Y. That's what we're trying to maximize. So what functions do we have? Well, first, we know x and y have to be greater than or equal to 0. You can't put a negative number of an item on a plane. But besides that, we've got the size restrictions. There's only 6,000 cubic feet. So the number of medical kits, each one takes up 1 cubic foot. So 1x plus 1y is less than or equal to 6,000. The second equation is the weight. Medical kits weigh 10, so 10x. Containers of water weigh 20 plus 20y is less than or equal to 80,000. Okay, so I'm going to reduce the equations as much as possible. This is y is less than or equal to negative x plus 6,000. If I divide everything by 10, I get x plus 2y is less than or equal to 8,000. So 2y is less than or equal to negative x plus 8,000. Divide by 2, y is less than or equal to negative 1/2 x plus 4,000. So these are the 4 equations I need to graph. So x is greater than 0 and y is greater than 0 is just restricting me to the first quadrant down in my graph. Y is less than or equal to negative x plus 6,000. I'm going to assume my y is going by thousands to make my life easier. So it'll be starting at 6 and have a slope of 1. So we start here. Negative 1, down 1 over 1. So that gives me what's created there. Negative 1/2 x plus 4,000. Again, I'm going to start at 4, down 1 over 2. To get this line. So I know I need to be below both of these 2 lines, but in the first quadrant. So that should give me this shape here. And we'll continue this in the next video.